Welcome, everybody. I'm very happy to have as our guest Vjeko on our 66th webinar. And yes, we met each other again in Birmingham at the Days of Knowledge, where I was very pleased seeing him presenting on writing testable code. And actually, that's something I would like to have on the show one day too, but this is something you need to go and witness in one of the conferences. So, but we discussed about having a session today about test doubling, or what we know as mocking. So efficient testing with test doubling. So welcome, Vjeko. I'll leave some part of the introduction to yourself, although I gather that a lot of people out here today are are knowing you already. Housekeeping rules. I'm the moderator. I will pick up the questions from the question window. So feel free to write any question you have in the question window. As you might know, your microphone is muted, so no way of talking to us this way. I'll pick up the question when they make sense in the context of what Vjeko was discussing at that point, or otherwise at the end in the Q&A session. So don't hesitate, be part of it and come up with your question. Yes, I'll do my best to get this recording out on YouTube as fast as possible. Might not fully succeed this evening as I have some meeting later on, but I'll do my best. And yes, if you haven't been subscribed to our newsletter, please do so. One session ahead on the 15th of May, there is a gap in between due to my holidays, but on the 15th of May I will sit down with James Pearson, picking up our session of the Days of Knowledge of Birmingham, and welcome you in our cafe where we're going to update each other on what we are doing currently with test automation. If you have any topics, you're welcome to step in, or at least tell me what you would like to have as a session on one of the next webinars. Nothing ahead yet after the 15th of May, but in the coming weeks I will be roaming around trying to get some people telling some of their interesting topics, experiences, whatever. So a short introduction for today. So before I'm going to hand over to you, Vjeko, I'm always thanking the sponsor for enabling us to do this webinar. So I'm going to change presenter and make you presenter, Vjeko, and looking forward to what you're going to tell. Have fun.
Thank you, Luke. Hello, everybody, and welcome to this webinar hosted by Areopa and sponsored by FONAV. And my name is Vjeko Slavovic, or Vjeko. You may know me from the community already. This session was born, or the idea about this session was born at Days of Knowledge when I discussed with Luke about a concept I was presenting, which was writing testable code. And I mentioned that I had to cut a large part of contents out of that session due to time constraints. And then Luke asked what it was, and I said it was test doubles. And now I believe that's an important topic and that could be addressed in its own right. And then Luke proposed that we do it together. And of course, I accepted. So here I am today on April 17th, ready to share my view on what test doubles are, how we can take advantage of them in AL, and what could complicate our life. So let's take a look at what we're going to talk about today. So first of all, I'm going to talk a little bit about what the test doubles are. So we or you probably know them as mocks, and people most often use the term mock, but that's a very narrow term to refer to test doubles. So we will see about them. We will see why we need them. We will see the types of test doubles we have and when to use which one of them. Of course, you will see that on a number of practical examples. There is also a repository that follows this webinar. I have included the link to that repository on GitHub in semi-last slide of this session. So you will be able to actually download the code and play with that code for yourself. And then finally, of course, I will address this a few pain points with test doubles and AL language, because even though we would love AL to be on par with, let's say, those tier 1 languages like C# or Python or TypeScript, unfortunately, we are not there. We are far from there, so we still have a lot of constraints, a lot of things that we would love to be able to do, but we are not able to. And I will address a little bit about that, about what I believe how we could make our lives as developers easier. So before I answer the question what the test doubles are, I would like you to consider this piece of code. So this is actually standard Business Central code from sales posting routine. So if you post with an option to send an invoice by email, then you have this. And there are these 2 lines of code that I would like to get your attention to. So consider that you have to write something like this yourself, that this is not actually standard Business Central code, that this is actually something that you have written yourself. So I will ask you a question. How will you test this code? So how do you write tests that actually have that are meaningful and that make sense for this piece of code? Because there are a lot of obstacles that you will encounter when writing tests for code like this. So for example, the test environment may not have email sending correctly configured. Like maybe your Docker environment will be fine, or maybe your cloud test instance will be fine, or sandbox, but maybe pipelines will not have correct configuration, so they will not be able to run tests correctly. You don't want tests to fail because of that. Then second thing is sending emails may actually be slow. It may unnecessarily slow down your test code. So you would send emails out, but that would make your test slower. And then probably the most important one is you probably do not even want to send emails while running tests, because that makes no sense. Then you do not want your tests to be fragile, because your code depends on some external component that you don't control. There are so many moving parts here in this email sending, and they're completely out of your control. So it is so easy to make your tests fragile. And the worst thing that can happen is that you get an email from a failed pipeline that says something, you broke something with your last update. And in fact, you didn't. It's simply a fragile test which started failing because it didn't handle dependencies correctly. Then maybe you would like to know how your system will behave in any of many scenarios when this external component fails. Like what will happen if setup is incorrect? What will happen if email server is unreachable? Maybe what will happen if account is no longer correct, etc., etc. So you may want to test how your system will behave in all of those scenarios. And finally, you may want to test other parts of the process. You don't really care about running email sending code. So you're testing everything but this. Yes, this line will happen here, but you don't really want it to send anything out. So now that you have seen the obstacles that we have when we have these kinds of external dependencies inside our code, let me try to answer the question of what the test doubles are. The easiest way to illustrate that would be to say that a test double is an object that stands in for a real object in a test, just like a stunt double stands in for an actor in a movie. So that is why we call them test doubles. This term was invented in 2007 by author named Gerard Meszaros, who actually is one of the top Agile guys. He's one of the authors of Agile Manifesto, and he's been involved in test theory for a long time before test doubles actually were conceived as a concept. So he was one of the first of those who actually not just formalized them, but actually classify them. So the test doubles that we're going to talk about today all come from his work back from the early 2000s. So now that we, at least in theoretical way, know what test doubles are or what purpose they serve, let's consider this piece of code again. So have you ever had a piece of code which looked like that? And here in this example, this email records function actually looks like this. It has this familiar handle pattern in there. So have you ever done something like this when writing test code? Essentially, subscribe to this function, or this event publisher, you set handle true to prevent any further handling to happen, essentially saying, don't send any emails, I'm not interested in that. If you have done that, then congratulations, you already know test doubles. So this is actually an example of a test double. The only problem here is that I like to call these things grab and handle doubles. They are mostly bad. So they are really not good doubles. And unfortunately, most of testing that I've seen in AL uses just this pattern. And then let's take a look why these grab and handle doubles are not really good. I'm going to present these obstacles that I presented earlier when showing that email code. And I will address one by one what these kinds of doubles, like this grab and handle doubles that I like to call them, what they achieve and where they fall short of what we may want to do. So first one is that we have noticed that one of the obstacles was that the test environment may not have email sending correctly configured. This kind of doubles fails there. It just doesn't tell you anything about the configuration. It simply puts it under the carpet, skips completely over it, and doesn't let you either test how setup works, how you should configure, etc. The second one is that sending emails may be slow and may unnecessarily slow down your code. Well, congratulations, you have at least solved that one. You won't be sending any emails out. So, yeah, essentially, this is handled true, has handled that scenario. You will have fast-performing tests. Also, you do not want to actually send emails while running tests. Of course, this is also solved. There will be none sent out. But how about the next one? You don't want tests to be fragile because code depends on some external component you don't control. Well, it doesn't really achieve anything there because you didn't really do anything about controlling that external dependency. You have just skipped running it, and that's all. So you cannot make your tests resilient to specific kinds of failures that you would like to see. So this is more about that in this next topic. Like you may want to see how your system behaves in those scenarios where this component would fail in real life. So again, this kind of a handle pattern will not achieve anything there. And then you may want to test other parts of the process and don't really care about running email sending code. Yes, you did achieve that. But these three most important ones, in my view at least, they are completely unaddressed. So if you ask me to illustrate it to you what these grab and handle doubles are in reality, imagine this car safety testing where you have this dummy walking across the street and then you are testing if your car will detect it and stop. So grab and handle doubles do this. They remove the dummy. So essentially, you will never crash because there is nothing to crash into, so your test will succeed. But they will not tell you anything about the essential part of your system, which you should really test. And this is why I believe that these doubles are not good enough. We will see a little bit more about them. They are not really all that bad. They have their place. The problem is they are something that I've seen mostly out in the wild, that people just do those. And this just doesn't achieve much. This actually hides the problems away. So it doesn't expose the problems that you should be, that testability or testable code should expose. They actually hide that all away from you. So let's take a look at why we use test doubles. The first reason is isolation. Test doubles will allow you to isolate the component you are testing from its dependencies. And this will help you verify that the code you are testing behaves as expected without being affected by the behavior of its dependencies. The second most important reason why we use test doubles is performance. Because test doubles will always require less setup. They will also require much less database setup, and they will run faster than real dependencies. So they will let you test your code more quickly and more frequently, which is more important because people often do not run tests frequently enough. They run them only at the end. So most developers I've seen will run tests, or not even they will get tests run for them by the pipelines once they push code. And this is far too late. So, and they don't do that because of performance. I've seen projects where running tests takes more than an hour. So obviously developers cannot just afford to run tests all the time. So that's why performance matters, and that's where doubles can also help. Then repeatability. Test doubles will allow you to consistently simulate specific scenarios that might be otherwise difficult to consistently repeat with real dependencies. For example, imagine you have a real posting process. It will always result in different posted document numbers. And test double can be made to actually return the same one, which makes setting up tests, executing tests, and running validations easier. I'm not saying that hard coding stuff is good. I'm just giving you an example of how a real process differs from test doubles. Sometimes you want to be able to repeat certain conditions with consistency, which real-life components may not be able to. Also control. Test doubles give you much more control over the behavior of your dependencies. You can, for example, simulate error conditions or edge cases that might otherwise be outright impossible to repeat without doubles. For example, you can simulate unreachable hosts or network being down or access control issues and similar scenarios that otherwise just using real dependencies may not be easy to do. And finally, flexibility. You can mix and match your doubles. You can make them as simple as possible or as complex as necessary, depending on exactly what you need to do and what you are actually testing at the moment. So let me give you a fairly simple example of something we can all relate to. Now I'm going to switch a little bit into code, and we will be discussing a little bit more of code. So let's take a look at this fancy currency conversion process. So for some business reason, we have come up with a process that whenever you have to convert a currency from one to another, you first have to check permissions, like you can set up who can convert from which currency to which other currency. Then you will perform this conversion, and then you will log the fact that you have converted. So extremely simple process, but something that we can easily relate to. I don't like complex examples for these kinds of webinars and presentations. So let's try to see what this code might look like if we wrote it 20 years ago. So maybe we would write something like this. We have this convert function, which accesses this table called permission. It filters to see if we have permissions. If we don't have permissions, it will throw out an error. Then it will run the conversion using Business Central native functionality. And then finally, it will log the operation. It will log the fact that we have actually converted. So this is a bad example of code. I hope you don't write your code in 2023 like this. But this is here just because we can see everything that happens in one place. That's the primary reason why I'm showing it like this. So please don't write code like this. There are many better ways to write that, but this is how developers still, unfortunately, by default, most often write the code. They have a function that needs to do something, so they stuff everything into that. When you think of how you should write test code for this, now we have problems because there is too much stuff happening inside here. So maybe some test code for this would look like this. So it would first create two currencies, then it would create exchange rates between two currencies, then it would set up permissions to exchange these currencies, then it would run the functionality. So when convert currency, we are actually running our convert currency code unit, and then we are asserting that conversion is actually succeeded, and then we also make sure that the log is written. So this kind of looks fine. You could be like feel proud, okay, I've written code for this untestable part of application code. The problem here is that this is not all. Like, this test code doesn't genuinely validate your application code. It only validates one possible scenario. So there may be more scenarios. Like, for example, you may want to see what will happen if from currency code is unknown or to currency code is unknown, or when you have no permissions to convert. What about logging? Do all of your tests actually test whether logging has occurred, or should you check whether logging occurred at all? Like, maybe you don't care about that while writing tests. So I call this way of testing, this kind of test structure, naive testing. And again, unfortunately, most of test code looks like this. It sets up some givens, like some records in Business Central, then it performs something on them, and then it validates the output, and it looks legit. Like, honestly speaking, like, yes, this test code at first looks legit, but this is very naive. And let's take a look at what is naive about that. Like, why is this test code bad? First of all, it requires a lot of setup. Every time you run a test function, you will have to set up those things, like set up the currency, set up exchange rates. And this is, again, a very simple example. It could be a more complicated example where a lot of setup would be required. I've seen tests starting with, 50 lines of setup code where they're setting up everything that is necessary to test a very tangled and tightly bound process. So the second problem is that your tests will inevitably contain a lot of redundant code. So if you want to test for all these scenarios, like test when there is no to currency, test if there is no from currency, test this, test that, you will essentially copy paste. I've heard developers or team leads refer to test code like copy paste code. Like, it's essentially like piles upon piles of code that was copied and pasted from another test. And in the end, this is also very unmaintainable. If you need to change something about all of these tests, there are plenty of places you need to look to actually change all of those things. And then these tests aren't really unit tests. The test code you've just seen on the screen, it's not a unit test. It's some kind of an integration test. It doesn't test one thing. It tests three things which are essentially independent one of each other. Then these tests depend directly on database operations. This is something which we will talk a little bit more about that. This is not completely avoidable. This is probably completely unavoidable with Business Central, but there are things we can do to make it better. Database operations are number one reason why tests are running slow. So here in my test, also a lot of database operations were involved. I had 2 currency insertions, 2 currency exchange rate insertions. I had 1 permission insertion. And then I did some reads to figure out if everything is in place. So there were quite a lot of database operations for something that I could have done probably without the database access at all. Then performance is low, and especially the more scenarios you involve, the slower it will all run. It will simply just start running slower and slower and slower. You're slowly, one test at a time, contributing to that 1 hour of runtime for your test suite. And then finally, most ironic of all, is that this test is actually useless. That test that I've shown you doesn't test a single thing, or maybe it does test a couple of edge things about my process. It actually tests standard BC behavior. Like, when you take a look at this here is something that Microsoft has already tested. So I'm essentially running Business Central currency conversion and making sure that it runs. And why should I do that? There are tests already in Microsoft's test suite that make sure that this is true. So why am I testing that? The problem is, a lot of tests that I've seen will test Business Central behavior as if this is the core thing that we do. The core of my process is not running Business Central conversion. It is to run this complex, I called it fancy conversion process, which contains multiple steps. And one of those steps is just making a conversion. But I should not be spending my time testing something that has already been tested. So if this component doesn't work, if this test fails on this assertion, then I have deeper problems, because then Business Central is actually broken. It's not my code that is broken. So let's talk a little bit about how we can improve the tests. First step in improving these tests, or maybe the test code you've seen, is to identify dependencies, to know what are the dependencies that my code handles. And then the second step is to decouple them. We need to separate the dependencies from your code, from your business logic, so that we can test them in isolation. So we need to be able to test individual components in isolation. This is what unit tests are about. They're not about testing entire processes. They're about testing individual components in isolation from each other and making sure that each component itself gets its job done. And then you have integration tests, which are to test the whole process. These are like my test here, the one that you have seen on screen. It was more like an integration test than a unit test. Actually, the problem there was that my code was not unit testable. It just did too much. And also, we can improve the tests by using test doubles to substitute those dependencies that we have identified as appropriate. And once you do this, once you do all of these things, this will not improve your test code. This will also improve your application code as well. So let's try to do this with this example. So how many dependencies can you identify in this piece of code? So I think that the first one is pretty obvious. This is check permission. So we have permission system, and it's the first dependency in my process. I essentially just have something out there that tells me whether or not I'm allowed to perform this process. And then based off the output of that process, I do something or do something else. And then obviously I have this one. I have logging system where I'm just, after my operation is done, I'm logging something somewhere. And yes, this is an obvious dependency. But there is this one. This is also a dependency. This conversion system, in my case, I'm actually using Business Central standard conversion process. This is a legitimate dependency for me. This is not my process. This is Microsoft process that my process depends on. So here in this case, I have a process which depends on 3 isolated processes. All of them can happen independently. Like permission system can be invoked not just from here. It can be invoked from anywhere where these permissions are needed. The same is true of conversion system. Like Business Central already involves this same conversion system in plenty of places, like hundreds of places are using this exchange rate conversion that I'm using here. So this is my dependency. So how do we identify, how do we know what is a dependency? People typically think that dependencies are third-party components which are not written or controlled by you. And this is true, but this is only partly true. This is not the whole truth. Dependencies are not just that. So essentially, anything that can be decoupled into an independent component or process is a dependency. And especially if you can then test that component once you decouple it, if you can test it in isolation, completely on its own, it is a dependency of your code. And also, if that same chunk of code, which you just decoupled, can be used from multiple different processes, it is a dependency. And also, if this chunk of code, this dependency that you've identified, can be exchanged by an equivalent component without breaking the process, then it is a dependency as well. And especially if your process can treat it as a black box, like it's just some black box, you throw some input at it and you get some output out of it, and you don't really care about how this black box did its job. That is a dependency. So in my example, I have these 3 dependencies. I have a permission checker, I have a currency converter, I have a logger, and by default, permission checker is a database table, currency converter is standard BC exchange rate, and logger is a database table. But I can freely interchange any of these, like permission checker could be Azure Active Directory, or currency converter could be some third-party web service, or logger could be telemetry, or whatever. And my process would still work. Like, it doesn't care where does permission answer come from. Like, am I allowed or not to perform this? And also, it doesn't care how the currency converter dependency converted it. Did it use some third-party web service, or did it use standard BC? It just gives same input and gets same output, and that's all my process cares. So this is how you identify dependencies. And once you do that, you can start decoupling them. So there are multiple approaches how you can decouple dependencies. And over the past, we have seen many patterns. If you go to Microsoft's Patterns and Practices Wiki for AL, you will see a lot of patterns, most of which aim at decoupling dependencies in one way or another. So we have had those facades and variant facades and argument table facades and stuff like that. All of these are decoupling the dependencies. They allow you to decouple your code from each other. But we have some more modern approaches like interfaces or events, even though I primarily prefer interfaces because they are the most versatile, the most robust way of decoupling dependencies. But I'm not going to say it's the only one. It's absolutely not. All of these listed here are legitimate. Even handle pattern is legitimate in some scenarios, as we will see. So here in my example, I've taken an example of interfaces. I've extracted the interface for the logger. So I have this iLogger interface, and I have a code unit which implements this iLogger. So this interface now represents a contract between my process and a dependency, and my process no longer will require direct access to database logger. It doesn't really care what the logger will be involved. And I will do this for all three dependencies, for permission checker and for currency converter. I will use the same approach. I will just extract the interface and then implement that interface in a default code unit, which will use some default functionality. The second step is to provide some kind of an inversion of control mechanism. So I cannot talk about inversion of control too much today. Like, this is really not a topic. This is a topic of its own. But inversion of control means that you need to have a mechanism which allows your code to receive its dependencies from the outside, so that your code does not decide about dependencies itself anymore. Like, if you remember the original code, where I directly depended on database for checking permissions, on database for writing logs, on Business Central to perform conversion, with inversion of control, my code, my process code, my application code does not make those decisions. Those decisions are made for it, so control is inverted. My code does no longer control these dependencies. So we need to provide a mechanism by which we will push dependencies into my process. So here on screen I have an example of a factory. So this is a factory pattern where I can set up a factory, and then I can have that factory perform or actually return dependencies for permission checker, for logger, and for currency converter. And I can set up the factory with different dependencies as needed. So this inversion of control mechanism must be flexible to allow you to inject test doubles into. So how would you use it? Well, in your app code, you would supply real dependencies, like maybe database, permission checker, but in your test code, you would supplant a test double. Or before this session today, you would probably say a mock, but we will see what kind of a test double you would really supply for permission checker, for example. So once you do that, once you have identified dependencies and provided this inversion of control mechanism, then you can refactor your application code. So this is my convert process after refactoring. It has one new parameter, which is inversion of control mechanism. I'm passing an instance of a factory into this process. And then in the next step, I will obtain dependencies. So as you can see, like, my code no longer depends on exact dependencies. It doesn't care which logger, which permission checker, or which currency converter it will use. That's the job of factory to decide for me. And since I have received an instance of factory, I can now talk to this particular factory to obtain specific instances that I will handle when performing the process. And my performance of the process is exactly the same as it was. I first test the permission to see if I'm allowed to perform the task. If I'm not, I will throw exact same error. Then I will perform the conversion, and then I will log the conversion, except I'm doing it with whichever dependencies have been passed into me, rather than by exactly or directly specifically declaring which code units or which specific behaviors to use. So at this point, we are actually finally ready for test doubles. So this decoupling process we have been through allows us to define test doubles. And this inversion of control will allow us to inject doubles in place of functional dependencies. And different types of doubles will help test different aspects of the system. So let's talk about different types of doubles. As I mentioned earlier, and as Luke mentioned in the intro, people often call them mocks because this is just the term that has been used the most, even though this is actually the least, like the least common one that you would probably see out in the wild. It takes quite the time to write a good mock. So let's take a look at the simplest of all, which is a dummy. So what is a dummy? It does nothing at all. So when you need a dependency, like when a process requires a dependency, but you don't really care about that specific dependency in this particular test, then you can use a dummy. Like you don't really care about logging. You will just run over that logging. You care about something else in your test at this moment. Maybe in some other tests you will care about logging, but in most of the tests you will not care about logging. So you can just pass a dummy into it. It will do nothing at all. It's simply there because your code requires that component, like a logger, maybe. So it is used simply to satisfy the requirements for presence of an object. It can sometimes be as simple as a parameter. Like, for example, here in my test code, like I'm testing that I cannot convert from invalid to invalid currency. So I passed 3 dummies, like dummy currency code 1, dummy currency code 2, and dummy user account. So I don't need to write any of those into the database to be able to test that this will fail. So this test is legitimate. So all of these are legitimate dummies. They are simplest of all dummies. However, not always dummies are this simple. Sometimes dummies can be an entire stand-in code unit. Like, for example, for my logger, I can easily define a dummy logger. So this is an implementation of the logger interface, which does nothing because I don't care. Like, when tests don't care about logging, I can supplant the logging with this dummy logger. And then you can see immediately where performance improvement will come from. Like I will never have to write to database in none of those tests that don't actually care about writing to database. So for all those tests which don't really care that a log has actually been written and actually to the database, I can just pass this one in. And these grab and handle subscribers, they are dummies, really. They are just dummies. They just say like, okay, I handled this. You didn't really handle anything, but you said that you did because you don't care about that part of the process. The problem with this grab and handle subscribers is that dummy is not the only kind of test double that you will ever need. Like, imagine this kind of a stunt double for Brad Pitt in his movies. That would not work. So dummies have their own place in test code, but not everything is a dummy. And when you start testing everything as dummies, you are not just missing on a lot, you are actually writing invalid tests, and you are probably not even validating your code correctly. So let's talk about another kind of test double, which is called a stub. A stub will provide predefined fixed state to consumers. So when you want to test specific behavior, in my example, for example, I want to test what the system will behave when a user has permission to perform conversion and what will happen if the user does not have permission to perform conversion. I can have 2 stubs, or I can have 1 stub which allows me to configure. So I have a stub which essentially replaces permission checker and answers with yes or no, depending on my requirements. So I use stubs when I'm testing for specific behaviors with some predefined states. For example, here, this is my stub permission checker, where I have this can convert function, which comes from permission checker interface. I can set up the behavior of this stub. I can say whether I expect allowed or disallowed, and then I return the configured value. And then I can modify the behavior of my runtime code without actually having to set up any database. I don't need to write anything to the database to be able to check that my process will fail if the user has no permission and will succeed if the user has a permission. So this is a stub. Another similar to stub is called a spy. These are dummies or stubs that will also record when or maybe even how some process was used. So they are typically used to verify that a specific dependency was invoked during a process. So for example, you may want to check that currency conversion was involved. So some converter, whichever it is, like it can be Business Central, it can be some third-party web service, you just must make sure that it was actually invoked in a process. And then you create a spy. You create a test double, which serves only one purpose, to tell you if some piece of code has executed. So this is a spy. And at this moment, I would actually like to jump into code and show you a little bit about how we can use these stubs and spies and dummies for our testing. This is my original code, and this is something you will find in my repository in GitHub. I will share the link in the end of the session. So this 0.1 here, this is I have all the code in one solution. Even test is in the same app. This is simply because of demo efficiency. I just don't want to handle multiple apps. I just want to be able to deploy everything at once. So let me show you what is going on in here. First of all, I have this convert currency 0.1. Actually, let me just show you this, because if you will look into my demo repository, there are 3 commits. You can check out into each of them. Step 1 is just this initial stage. So if I check out to that, I will see that I only have this currency conversion, and I have this currency exchange log table and page, and permission table and page, and I have a test, which is this test, which you have seen. So I create 2 currencies, I create 2 exchange rates, I create the permission, then I convert the currency, and then I test whether conversion performed correctly, and I check if log entry is written. I have also added other tests. So I also test that when there is no permission, it fails. So I have assert error here. And I also have when there is no from exchange rate, this will fail. And where there is no to exchange rate, it will fail. So I'm essentially testing all possible ways how this code can be invoked. And this is this default state, like initial state from where I actually started. So I'm going to check out into this, or detach my hat into this second commit, where we can see a little bit more about that. So one thing that I've done is I have added this iLogger interface. I have added this permission checker interface. They have simply use this one single function, which was extracted from how original code used it. And then I have this database permission checker, which essentially is exact same code as my original code. Yeah, here I have find first instead of is empty. I apologize for that. And then logger does the same, database logger. Essentially, this is copy paste of this code here. So except that this is now abstracted away, and actually it's a dependency that implements this interface. And I have my factory here. I have a factory which can return the logger, permission checker, and currency converter. I also have currency converter interface, which receives all the inputs and then performs everything it needs to perform with all of those inputs. One thing that you can see from these functions, which you cannot see from here, is that all of these functions are now pure. And what do I mean by that? If you know a little bit about functional programming, you might have heard of pure functions and side effects. The thing is, this code, this function is not pure. It doesn't, it can have different side effects depending on, like, you can have same input, but you can have different outputs out of there. So maybe this one will be the same, but this is a side effect. This is something that happened independent of this, and this may look different based on the input, because there is a field in this table which is this integer, which will be different every single time. Here, all of these functions are pure, which means for same input they will always give same output. Okay, the only difference is this one. This is not entirely pure, but this is as pure as it can possibly be. The reason why I'm talking about pure functions is that pure functions are easy to test. To write a test for a pure function, you simply need to make sure that you test for all possible inputs and all possible outputs that make sense. Of course, you will not test for every currency code there is or every amount there is, but you will test for what happens when this is blank, what happens when this is blank, what happens when both are blank, and maybe what happens if this one is 0, etc. Like, maybe there are very few, or maybe for logging there is only one way how you want to test it, to make sure that whatever was provided as parameters will be found in these fields as output. But this one, for example, is completely pure. Like, it just calls Business Central, it gets these inputs, so everything comes from its parameters. All of inputs are public, they are not hidden. And this is easy to test. It's very easy to write a test for that. And I dare saying you don't even need to write a test for this, because the only thing it does, it invokes some dependency which has already been thoroughly tested. So you don't even need to write a test code for this code unit. But for this one, and for this one, you may want to write tests. So let's take a look at tests for this second stage. I forgot to show this. I have this factory code unit, which has logger and permission checker and currency converter. And I have set logger and set permission checker and set currency converter, where I can actually set these inputs and assign them to local variables, which I can then return. So whoever needs this factory, and this is my currency converter second version, when I pass this factory in, I can easily just extract these or obtain these dependencies out of the factory and perform the work using actual factory. This factory, as you can see, will return the default database permission checker or BC currency converter or database logger in case I don't set it up. But if I set it up with different dependencies, then it will use those dependencies instead. So let's take a look at my test. The first test is to make sure that permission checker succeeds when I have specific permissions to test. So from this currency code to that currency code, for this user, I'm inserting this. So I'm allowing this user to perform these. I do not need to insert a currency first or to insert an exchange rate to test that permission checker will work. So these are dummies. Like, I just pass dummy values into my currency code. I'm assigning, not validating, because I don't care about validation. This first doesn't have any validation logic, then any validation will be taken care of by Business Central at runtime. So I don't really need to test all that. There is no need to validate. I can just pass in dummies and have a very efficient test. A test which will simply check that I can convert from this to this currency for that user. And then I check that the result is true. And then I check that result is false. So when there are no permissions, when I use dummies, I actually get false, not true. So that's my permission checker. I have database logger tests. So I'm testing my database logger once to make sure that everything I passed into it, all of these dummies, are actually written in there. So all the values I passed in are now found in the output, and this validates that this logger actually does its job. And then I can start using my spies and stubs and all to test the business logic of my process. So let's take a look at one of the components. Like, I must make sure that conversion will invoke logger, so that my logger will run whenever I run my my conversion code. So I have a test double called spy logger, which implements logger. It says that logger is invoked when this function is called, and then I can check if it was invoked. And then from my test code, I can actually see that I am setting up this stub. I'm setting up my factory. I'm not giving any given to this intentionally, because this is not a given state. This is essentially just a test setup. This is also something I discussed with Luke. I don't really like this given when then for unit tests. This is more for integration tests. That's why you will not see a given here. It's just a plain factory setup. This is me just setting up my test, nothing about the process. And then I'm performing the conversion. And then I just want to make sure that logger was invoked. And with this test, which tests that logger was invoked, and the database logger test, which tells me that database logger works correctly, I have tested it. I don't need to run this database logging anytime in the future tests at all. I have tested it once for database logger and once to know that it will be invoked when it needs to be invoked. And I don't ever need to test that again. So in all of my future tests, I will use a dummy logger, one that doesn't do anything. It's there simply because the process requires a logger. And that's why I have a dummy. I'm passing a dummy into it. This dummy logger will not do anything. So it will just be present when this convert invokes this logger.log. So this is what my dummy does. And then I will assert that my converter was invoked. So when I have a permission, this will succeed. Again, when I'm testing permission system, I don't care about actual conversion. I don't care about invoking Business Central, setting up currency, setting up exchange rates. That's just junk. That's just noise. For my test, I only care that permission to perform is true, and that when I actually perform this, call this process, that it was actually invoked. So whichever dependency in runtime will be performing currency conversion will actually do its job. That's the only thing I need to test. Then, if no permission, then failure. So I set up my stub permission checker with no permission, so I leave it as default, and then I assert error. This will fail because this one will return false. So essentially, this one will return false, and I will get this error. So I'm asserting that error. And this is all. So I don't need to do more. And you will see later when I run these tests what the difference in performance is between tests written like that and tests, those naive tests that I wrote before. And also, these tests actually test my process, whereas previous tests mostly test Business Central, which I shouldn't test at all. So this is how I'm using dummies and spies and stubs to improve both my test process and my application code. Let's talk about more complex types of doubles. First of which is a fake. A fake is a working implementation, which typically takes a lot of shortcuts and corner cutting, but it actually performs real work, just not in exactly the same way that real system will do. So, like imagine that, like the simplest example that you will find when talking to, let's say, C# developers is what they will fake is a database system, because they don't need a database system to run tests. They will have a fake database system. So anything that is written to the database is actually written to the fake. So they don't need to have an existing. So they need to be able to write to it, to read back from it. It should behave exactly like real database system would behave, except that it's not a real database system. The interface is the same, so you can communicate with it in the same way. For us to say that the database is something we would fake, that would be an overkill. This is something we cannot do. But there are many things we can fake. So what do fakes do? They typically replace a complex or a long-running process that is a part of operation being tested. So it's something that must happen. But we don't care about how these results were achieved. We only care about the end results. We just need to get them, but don't care how we got them. So, like, if we have one process, A, that depends on the result of process B, but we only need that result because it belongs to A needs it. We don't really need to know or care about B, then we would create a fake for this B. This is a little bit abstract, so let me give you an example. Like imagine we're still talking about our currency conversion. So we have this currency conversion process, which we are now using inside of a sales process. So it depends on results of currency conversion. And it must only succeed when there is exchange rate between currencies. So this sales process doesn't care about how exactly this currency exchange is performed. What we could do is we could provide a stub permission checker to allow the conversion. We could provide a fake currency conversion that will give expected results, just like Business Central currency conversion will provide. It will throw an error when expected. It will throw give result when expected, but it's just fake. It's not involving database at all. And then test code will validate the sales process in these two scenarios, known currencies and unknown currencies, and it will be as legitimate as if it used the actual process, except that it was easier for you to set up a failing case, to set up a succeeding case, and then it will perform much faster to run both of those cases than if you had actual process being involved. So this is a fake. And then let's talk about mocks. Mocks are essentially just more complicated fakes. They are fakes which are pre-programmed with certain expectations. So they often provide full-blown functionality, and you typically use mocks when there are multiple dependency layers. So for example, you have one process, A, for example, that depends on another process, B. But behavior of A does not just depend on results of B. It directly depends on behavior or configuration of this B. So you really need to test multiple things. Like, for example, imagine that we have REST-based currency conversion component. So the system must be resilient to all known failures. Like, you must be able to know what happens when network is down, when API key is invalid, when invalid response body is returned, endpoint was not found, whatever. Like, all of these are possible ways in which the system can fail. So what you can do is you can provide a mock HTTP layer and then use actual REST-based currency conversion component, inject this mock HTTP layer, and then run different tests to mock different failures, and then test for expected behavior of REST-based components. So you want to see how your REST-based conversion will behave if network is down, for example, or if system or if BC environment prevents calling of HTTP client. So let's take a look at this last demo where I will show you how you can use mock doubles to test HTTP communication, and then you can compare test performance of different scenarios. So I will just go to this last. Is there a question? Look.
No, there's no question. It's only keeping an eye on time.
Mm-hmm. I'm really at the end. So
by the way, there is one question, but we keep that at the end.
Yeah. So I'm really at the end. So we have 4 minutes left, and I don't need that much. So let's take a look at my third example, my last example, which is my using mocks. So let's take a look at what I have here. I will restart this, and then we can take a look at my currency converter interface. I have another one. BC is one you have seen earlier, but this is a new one. So this one has a convert method which actually invokes HTTP. So it has this URL, it has my API key, it performs the actual GET method, except that it doesn't do it on HTTP client. It uses this interface called HTTP invoker. I only have GET method here for simplicity purposes, so that it's easier to follow. But this one has exact same signature as HTTP client GET. So slightly different because I have a response, but I don't care about response. I only care about JSON object being returned. So I did wrap a little bit into this, but essentially it's the same signature. So I can invoke it in the same way, and then I receive that JSON, and then I can parse that JSON to extract information from it, and then I handle that. And then I have my HTTP client, HTTP invoker, which is just an implementer which uses actual HTTP client to perform this. And then if it's blocked by environment, I throw this error. If it's not success status code, I throw this error and I show which status code that is. Otherwise, I read the body and I essentially parse it into a JSON object. And this could also fail if it's not valid JSON. So we can test all of those easily. And then I have my mocks. I have my, for example, 401 mock. Since this is a very simple, like this mock looks almost like a stub. I have explained this in the README if you care about reading that. So mocks can sometimes be simple. So imagine that my HTTP invoker had full-blown functionality of HTTP client. Then this mock would also have to do a lot more, but it doesn't. Like, I only care about this simulating a 401 error, or I want to simulate this blocked by environment, or I want to simulate like valid JSON or invalid JSON. So I have success, like this is valid JSON, but this is not. Like this JSON doesn't contain everything I need. And then I can easily write tests. I can see that, of course, I'm testing for my database permission checker and failure. Essentially, I have all of my first 6 tests are the same tests from 0 to, just for performance comparison. And then I have more tests. I'm testing for success. I'm testing for 401. I'm testing for invalid JSON, and I'm testing for block by environment. And now let me run these tests. I'm going to run all that, and we will be able to compare the actual performance of all of these three stages. So this machine is extremely fast, so please don't pay much attention to these numbers. They are actually, tests are very simple, even those slowest ones, but let's run it. Okay, now I have this. I will just do one run and stop this, and then I'm going to run it once again to warm it up. So now I will collapse these so we can see. This is my database process. Actually, everything is database driven. This is not database driven, and this is also mostly not database driven. So we'll run it again, and then you will see that this one will mostly be slow. And if you take a look, like all of these will be slow. And these are slow, like these numbers mostly come from overhead on running a test code unit, and here as well. So these are really blazing fast. Like whatever you do from here, from within them, and since you will have access to this code, you will be able to try it out yourself. When you apply test doubles to your test code, you will have better tests. Like here, I have only 4 tests which run 3 times as slow or even more as this one, which essentially tests everything and only has minimum necessary database testing. Like it has some database testing here and some database testing here in these two. And everything else doesn't even require database at all. So this is how you can use test doubles and mocks. So where does AL make it complicated? Well, it's sometimes not directly possible to use doubles because database is this most typical dependency. Other systems can easily fake or mock the database. We cannot that easily do that. And also the biggest dependency we have is the base app. There is so much code in there that we always depend on. And it's our biggest dependency. So make sure that you're not testing that as much, but that's not always easy. And furthermore, this base app mostly still has this legacy structure. It's very tightly bound, these gargantuan code units and functions that are just untestable. So how you can address that? First of all, you can add layers of abstraction. So just like instead of calling base app directly, you can wrap the calls into isolated components, just like I did today with this currency exchange. I wrapped it in an interface and a code unit which implements that interface, and then I was able to actually supplant it with something more efficient in my tests. So use interfaces where possible. Wrap database write operations into isolated methods if at all possible. Especially put them behind interfaces, and then you will be easily able to mock them or fake them or double them in any conceivable way, depending on what your test requires. Also, make your functions pure whenever possible. Pure functions are easy to test. Impure functions are difficult to test. And then also, like one very random one probably is pass record parameters instead of code parameters into your test, into your application code functions. I'm not talking test functions, I'm talking application code. So if you have to do a get from your code, then you cannot substitute that with a double. But if you don't need a get, which is frequently when you pass a record, then you probably don't need to do a get, then you can substitute those with dummies in your test code, which will just make it run faster. So some takeaways from this session today. First of all, application code written with test doubles in mind is more modular and generally better structured and better overall. The second one is that test doubles will just give you this much needed performance boost so you can run tests more frequently. Literally, you could write hundreds of tests which perform in seconds or maybe minutes, but certainly not hours. Also, different types of test doubles serve different purposes. Make sure that you understand what are different components that you test. Sometimes you will want to test whether or not specific part was invoked, then you can use a spy. Sometimes you can ignore a specific part of the process, then you can use a dummy, for example. So just make sure that you can tell the difference. So not everything is a dummy. You just cannot test everything with a dummy because dummy is just putting things under the carpet, hiding it away. And then, of course, test doubles allow you to test your individual components in an isolated way. So you can really just write those focused, narrow tests for database operations, and then test your processes with different doubles to be able to test all various aspects, to simulate all possible environment setup states or failures or whatever, and be able to test your component predictably in all of conceivable use cases. Demo code is here. It's on my GitHub. So al-test-doubles. You can download this here and then try it for yourself or analyze it a little bit deeper, because I had to run over that a little bit faster today. So that was all I prepared. Thank you very much for your attention, for everybody who remained this long. And now I will take questions.
Yeah, and most of them stayed quite long, so you really got them. There was one question from Tine Staric. Since we have to manually implement test doubles in AL, should we implement multiple types of a single object, a configurable stub that's also a spy, for example, or should we keep the implementation separate?
So I will give a political answer to this question. It is a legitimate question, but it's just the same question as what about our application code? Do we isolate business logic into multiple objects, like code units maybe, or do we stuff everything into those big management code units? You know, like I would say, if you can afford to split it up, then you should. Like if you can split it up into multiple stubs, multiple fakes, multiple spies, then you should do that, rather than implementing multiple interfaces on one object. It will just be easier to follow, more maintainable and everything. However, of course, your licenses may not allow that. So if you have license limitations, then you will have to cut corners. So I would say I would prefer to see them as separate objects rather than stuffing everything together, like having one big double, like one big stub or one big dummy for everything. That's something I would not be too happy with, simply because it's very difficult to follow your test code. Like 3 months after you wrote it, you still need to be able to read it. And then if you use the same double for everything, it would be more complicated. I would say, like, split it up if you can afford. But if you cannot, well, do what you have to do. Like how we had to do that for all of those years that we had object IDs and licenses that govern them. So, yeah.
Thank you very much. No other questions. And I also don't have a question. I was very pleased with what you showed us. I think this is a kind of rumbling in the earth that makes us shake and reconsider the things we're doing. So thank you very much, Vjeko. Thanks everybody for being here. Let me officially end today by switching to my own view out here. So to be able, that's the challenge probably. I showed my screen, but it skipped my last slide. So thanks everybody. I will do my best to get the recording out as soon as possible. There was one note from Gert. Thank you again for a great session. So you're more than welcome.
Thank you, Gert.
We're going to close down. Thanks once again, Vjeko, and well, hope we're going to continue this somehow.
Happy testing.